Okay, so today we are looking at a new way of describing a sample space. You can see the heading up there. Two-way tables, they're sometimes called, or Karnaugh Maps is the other fancy schmancy way of looking at it. So I'm going to hand out a worksheet right now because the worksheet has an example at the start of a Karnaugh map or two-way table. Like I did with the Venn diagram example, I'm going to unpack that example for you right now so you can see how it's constructed in practice. And well done on remembering our room change. That's a bonus.
Richard, you did not have our summary books at the end of last term.
I don't believe so, but I can look at my office later. You're welcome. Okay. And voices off. So as I've got here, basically all of these things are different ways of capturing information, right? So you've got information in a problem and you need to organize the information in a way so that you can answer you can either answer counting questions, which is like how many people did this or how many people did that or how many things, or to answer probability questions, because you know that if you know how many people match a certain condition and you know the total number of people, then you can use those two facts to work out a probability calculation, right? So it's for counting and it's for therefore for working out probabilities. Sometimes you only need to do the counting bit. Okay, but to be honest, the stuff that we do here could be done in a Venn diagram instead. But sometimes it is easier to capture it in a table because the layout is differently organized and therefore it's a little bit easier to work out what you need to work out, or quite simply because you're given a table full of information and you need to make sense of it. So that's why we're going through it. So what I've said here, down here, is that it's good for ordering information, or I should say organizing more than ordering. I think that's what I meant to say. Oops. So awkward. Good for organizing. Good for organizing information as in or out. So it's sometimes they're kind of called truth tables as well, in a way, in that you basically have it's not truth as in whether you're lying or not. It's a computer science term in terms of things being true or false, and it's like information is seen to be as part of a set or as not part of a set, which is kind of like true or false. It's true if it's part and false if it's not in computer science terminology. So yeah, it's good for organizing information as in or out, belonging to a set or not belonging to a set. Okay, so that's all I've got for Y. Now I'm just going to zoom out now so you can sort of see the table as well from the booklet. Now just for the purposes of the video, I'll just read out rather than write the example there in example 1. 100 grade 9 students were asked about their summer holidays. 45 had gone to the mainland and 12 had had holidays on the mainland and in Tasmania. 15 students stayed at home. How many students had holidays in Tasmania? All right, that's all right, isn't it? So that was the first read through. We understand, I hope, the concept of holidays. We understand what the mainland is and having a holiday at home. We know what summer holidays are. So the first read through in terms of literacy, we get a sense for what's going on there. And the last bit, of course, is really important, which is how many students had holidays in Tasmania. So we know what we're aiming for. So the next read through, we're just going to fill in the information, and I'm going to do it I'll keep it in blue, I think. we're going to do it just from the facts only. No calculations, just facts. You can see I've drawn up my table. So in terms of drawing it up, I notice that I'm talking about 100 students. I'm noticing that we're talking about the holidays and that we've got two different kinds of holidays, one in Tasmania and one at home. Noticing that 15 students stayed at home simply means that they belong to neither set. So we don't need to have a third set there. We just say they're part of the not set. Okay, so we've basically got two distinct groups. Holiday makers on the mainland or holiday makers in Tasmania. So I create my my two-way table this way. So I use two columns to describe one of those sets. So in this case, mainland. I'm just drawing on the screen now so you can see what I'm talking about. So this column here will have all students that went to the mainland for a holiday. Here are the students who did not go to the mainland for a holiday. So you can see in and out. And then in the rows, you've got Tasmania and not Tasmania. So this is the group of students who holidayed in Tasmania. This is the group of students who did not holiday in Tasmania. Now, what we do is we look at the intersection of the column and the row. So, for example, this spot, I'll go for this spot. This spot here would be students who holidayed on the mainland but did not holiday in Tasmania. Yeah? So we read down the column and across the row, or the other way around, across the row and down the column. But that's what that cell means. That's what that box represents, both of those conditions. So let's go through it again and let's see what we can just fill out. It said 45 had gone to the mainland. Now, we're not told, we're told that's a total. We're not told that it's mainland only. We don't see the word only there. And so it must be that the total number of students who went to the mainland must be 45. So I've got to write 45 down here. Does that make sense? Yeah? Okay, let's go to the next fact. 12 had had holidays on the mainland and in Tasmania. Who reckons they know which box that goes in? That was really quick. Can you write 12 in where you think it goes, Thomas? What do you think? Is he right? Are you sure? Oh, damn it. It does say on the sheet. Yeah, no, that is right then. Yeah. It's 12. Oh, you got to hide. Oh, no, you can't even hide it because it's in the first box, isn't it? 15 students stayed at home. Okay, so I won't ask who knows where that goes because it's on the sheet as well. So stayed at home means they did not go to the mainland for a holiday and they did not go somewhere in Tasmania for a holiday. So the only spot that could go would be not mainland and not Tasmania. So where those two facts intersect is in that box there. And so we write 15 in there. Does that mean, like, if you could just ignore the bottom box, please? In fact, now that we've got our information in, let's put our booklet over so you can't work it out from there. Okay, there's one other fact that we haven't recorded yet, and I'll just stick it in now so that you've got it, and that is we were told that 100 students were surveyed, I think it was surveyed, or there were 100 grade 9 students. So that means that in the totals column, we have to have in the bottom right-hand corner the numbers adding up to 100. In other words, if this is the total of people who went to Tasmania and this is the total of people who did not holiday in Tasmania, these two must add up to 100. If this is the total of the number of people who went to the mainland for a holiday and this is the total of people who did not go to the mainland, then those two have to add up to 100 as well. Does that make sense? Who reckons, this is going to make me walk around I'm going to do the next step in red. What we do now is we go through our table and fill in any blanks that we can. And what we're looking for is a column or a row where there's one blank out of the three, because then you can do some calculations with the other two to work out what the missing box is. So I can see at the moment 2 boxes that could be filled in. Who reckons that they could fill in one of those boxes? We'll go with you, Billy. No.
Oh, okay.
Let's see where she's going to go for.
Can I write the working out?
If you like, yep. There we go. Now, I have to say, I'm absolutely happy with that working out as Billy's done it. No problems at all. And that's perfectly correct. Okay, so that's 45 in total. 12 plus 33 equals 45. It's okay to do that in your head instead. You know, you can just go straight for putting in the number. But particularly since this is a worked example, I'm really happy to have that working out there. Who can fill out another number? There we go. So there's now 2 numbers still that could be worked out. Which one's Blair going to choose to do? No, because there's 2 you can do. There we go. So there's a missing number there, 45, and we knew it had to add up to 100. So the missing number there is 55. There is still 2 numbers that can be calculated now. Now, from this point on, we have to use a combination of blue and red, right? We've run out of facts that we can use just with blue, but now there are some red ones that combined with the blue ones that will give us some of those missing boxes as well. Who'd like to calculate another one? Which one's she going to choose? 48. Thank you, Charlotte. So 33 plus 15 is 48. That's right. So that's good. Now we can fill in the other 2 boxes. Someone to fill in one more? And then pass it over. Riley can do the last one. Thank you very much. So the 40 would be because we had 15 and we knew the total was 55. So if we have 15 here and 55 here, there must be 40 left over that we did not go to the mainland. And then now that we've got the 40, we can say 40 plus 12 is 52. We okay, boys? Okay. So there you go. The full table is now worked out. You can flip over your questions again, and you can see that should confirm what was on the thing as well, I hope. And it said how many students had holidays in Tasmania. So we can now use the total over here to answer the question, which is 52. And you could also answer a whole bunch of probability questions as well. So for example, if I said to you, of those 100 students, a student is chosen at random, what is the probability that that student holidayed in Tasmania at some point? The answer would be 52%, right? Because it's all out of 100. So 52%. If I said, what's the probability of choosing a student who travelled only in Tasmania, then that would be what? Only in Tasmania? 12%? Okay, because only in Tasmania means they did not travel to the mainland. So that would be, I should say 40%, beg your pardon. 40%, Tasmania and not mainland. Yeah. And if I said, that was given to you in the question, I know, but if I said, what is the percentage of, if I picked a person at random, what's the probability that I choose someone who stayed at home for the whole holidays? It would be 15% from this table. So you can read lots of different information from this table to get your answers. Any questions? Anything at all? There's no such thing as a silly question. Just a question that is unasked is quite silly. Okay, I'll just stop this recording. That's basically it. So for the rest of this lesson, you've got example. Oh, sorry, I should just say, and I deliberately did not go through this. On the second page, there is example 2. Example 2 goes through a more complicated Karnaugh map, and I think I'll just leave it for when you get up to the more difficult ones, then you can go read through the example and get me to come and show you. Because basically in example 2, it says, well, what happens if there's more than 2 groups? So in a Venn diagram, we just draw 3 circles. We just extend the idea to 3 circles. But a Karnaugh map really only works on 2 bits of information. Okay, well, you could do it, I suppose, if you made it three-dimensional, but as it stands, flat on paper, it only does 2. So what, I'll just give you the broad idea, but I won't go through it. What it does is the 3 groups here are the kinds of holidays. It was beach or hiking or Queensland. There were 3 groups. So what they did is they split it up into beach and hiking as 2 things to look at. And then they split it into 2 tables. Did they go to Queensland or not go to Queensland? And then you can sort of use both tables at once to try and answer questions. So it's more complicated. I'll be honest, if it were me, I'd just go and do a Venn diagram. I think that'd be simpler than splitting into 2 tables. But nevertheless, just so you're familiar with it and you've seen it, there it is for you. And I'm happy to talk you through it if and when you get that far. I'll shut up. I'll put have I explained appointments list to this class? To the newbies? You're not a newbie? Okay, just for newbies, I'm going to write an appointments list up on the board. That simply means that if you're waiting for help, rather than sit there with your hand in the air like you just don't care, you can come and write up your name on the board. If I'm not seeing anyone, just stick your hand up, I'll come and see you. But if I am seeing someone, writing your name on the board gives you a place in the queue. Okay, so you use that, because if you stick your hand up and I walk past you, it's because I'm going to the person on the board first. Okay, but if there's no names on the board, just stick your hand up and I'll come straight to you. Come see you? Yep, no worries. Get to it, guys.
Blake, I was interested in I just want to put posts up to the classroom.